Right, here's a probability tree question, and I hope you're lucky enough to get one of these because these are usually very valuable, very high marks for not very much work. So the first thing I'm going to do is read the question quite carefully and write down exactly the probabilities in bag A. So there's 10 counters, so we're out of 10, so that's the denominator, and there's 7 of them are apparently odd. And if there's 7 out of 10 are odd, that means there must be 3 out of the 10 must be even numbers. And bag B, same process. I'll write down the probabilities first. So we've got 12 counters, so it's out of 12. We've got 7 twelfths are odd, and that means that the remaining 5 out of the 12 must be even. We've got that information. We read carefully to see if there's replacement or not. There isn't in this one. It's just a question of taking something from bag A and bag B. So look where I've written the bag A and the bag B. And this is printed for you on this particular exam sheet. Okay, but you always label on top of the branch, and the outcome is put at the end of the branch. The probabilities are written on the branch. Okay. Right. So I'm just sticking in the probabilities in the spaces, and this is worth 2 marks. Okay. So that's what's been printed for us. I'm going to write my probabilities on here. Yeah. So bag B, 7 twelfths odd, even 5 twelfths. Okay. And I should have done the same for bag B as well. So you fill that in like that. Now we're going to calculate the probability of getting an odd score by taking 1 counter from each bag. Now if you think about it carefully, there's only 2 ways to do this. Either you're going to get an odd from bag A and then an even from bag B, or you're going to get an even from bag A and then an odd from bag B. You just literally write down the probabilities. So odd bag A is 7 tenths, and then we're going to have, I'll talk about that in a second, and the multiplication, and then 5 twelfths. That's an odd followed by an even. Now in probability, if you say the word and, it means times, and if you say the word or, it means add. They've asked us for an odd and an even, or an even and an odd. So I need to work out the each one. So an even followed by an odd would be 3 tenths and 5 twelfths. Okay. Okay, so you do those, multiply those fractions, 21 out of 120. Now, we want both of these. We want the first situation or the second one. That means we're going to add these 2 results together to get our answer of, what's that, 56 out of 120. Of course, I'm going to use my calculator to see if I can simplify that fraction. So 56 out of 120, and that equals 7/15. Yes, it does. Okay. Good. Right, let's look at the next part now, which is part C. I've got quite a lot to read there. Harriet also has a bag of counters, and this looks like it's and means multiply. So we've got a lot of multiplication of fractions to do and solve an equation. So let's write down the situation. We've got bag A, and we want to choose an even one from that, which we've already worked out. Then we're going to choose one from bag B, and that's going to have to be even as well, and we have that probability. And then we're going to choose one from Harriet's bag, and we don't know what that fraction is, so I'm going to have to call it x, aren't I? Some fraction I don't know. Okay. Apparently, if you add those together, if you multiply those together, because we're saying and, if you multiply those together, then we should get 3 out of 100. So I am going to multiply those together because and means multiply. Alright. So if I multiply those together, Well, I can certainly do 3 over 10 times by 5 over 12 times by x. So that's going to give me what, 15 out of 120? X equals 3 out of 100. Okay, and of course if I divide by 15 120ths, I'm going to find x by itself. Okay, so that's a question for my calculator, isn't it? Don't have to do it in my head. So there we go. Just checking that I'm right. It tells me 6 out of 25. So 6 out of 25 counters must be even. So for every 25 counters Harriet has, 6 of them are even. So the least number of counters she must have in her bag must be 25. Maybe she has 25, maybe she has 50, 75, 100, and that's the ratio of even to odd. It's 6 to 19, isn't it? So she's got 6 out of 25, so I'm going to say 25 counters, the least number of counters she must have in her bag. And there we have it. Okay, so let's have a look at the examiner's report about this. So the tree diagram went well for most students. And so part B is where it starts to go wrong for some people. The only way you're going to get an odd number is if you add an odd to an even or an even to an odd. If you add 2 odds together, you're going to get an even number. If you add 2 evens, you're going to get an even number. So you have to know that. Okay, and just checking we've got the answers right, and it does. It looks like we did get them right. And in fact, they use exactly the same method that I did. Look at all those method marks. You're going to have to show a lot of working. Otherwise, you're going to lose out on 8 marks, which is a gift.